Good morning. Today we're going to talk about section 7.4 in Math 101, chapter 7, section 4. We're still going to factor trinomials as we did in section 7.3, but it's going to be trinomials where your lead coefficient is not equal to 1. You may recall in section 7.3, we restricted A to be equal to 1. Here in section 7.4, that lead coefficient is not going to be 1. And that may complicate things a little bit. Certainly, they're more difficult factorings. Typically, stuff we've done before in our math careers. Let's look at example 1. This is on page 426. We're going to dive right in. Factor this trinomial expression, 3x squared plus 20x plus 12. All right, here it doesn't make sense to look for factors of 12 that add up to 3. That scheme only works when your lead coefficient is 1. 3 helps us in that 3 is a prime. So basically the task is similar. We're going to try to unfoil this trinomial via a trial and error method. Since 3 is prime, I'm going to have to put 3x and x in the first slots. All right, notice this sign is positive. That means both these signs have to be the same. Either positive, positive, or negative, negative for the last product to be positive, right? Notice also that this sign is also positive. Well, that means I can't have negative, negative between those binomial factors. They must be of the form positive, positive in between. All right. So let's go on with that assumption then. Must be positive, positive. All right, I need factors of 12 here such that the inner and outer products are going to add up to a 20x. And really, that's the real battle here. We know the first product is going to be all right. The last products we'll make sure are positive 12. Well, let's see. What possibilities? We got a lot of possibilities here. 12 and 1. And because these first terms are different, I have to allow for different orderings here. 1 and 12. 6 and 2, 2 and 6, 4 and 3, 3 and 4. Well, I've only got one possibility that works, and I believe it's 2 and 6. Let's check it. The outer product here would be 18x, and the inner product here would be 2x, 18x, and 2x do indeed add up to a 20x. All right, so let me rewrite that expression. I need 3x and x in the first slots. I need plus and plus in the in-between signs, and 2 and 6 in that order. It has to be in that order. 2 and 6 definitely work. If we check our answer here, first product is 3x squared. Outer product is positive 18x. Inner product is 2x. And the last product, 2 times 6, is 12. And indeed, 18x and 2x add up to a 20x. So indeed, this is the correct answer. All right, let me rewrite that. All right, I'll just erase those notes and just box that as my correct answer. All right, so a little bit more difficult. The spirit of these problems is the same. Clearly, this lead coefficient that's not 1 may gum things up a little bit, but with enough patience and practice and trial and error, we should be able to grind through pretty much everything that's thrown at us, right? All right, let's look at example 2. On page 427, we are asked to factor the trinomial expression 5x squared minus 7x minus 6. All right, 5 is a prime number, so if I'm going to break up the first terms, I'll need a 5x and x in the first slots. All right, if this this constant term, if the polynomial is in standard form, and the last term is negative here, you'll need either plus minus or minus plus in those middle signs, and you have to allow for different orders here because the first terms are different here. All right, let's take a look here. 6. What I'm going to do is look at factors of 6 and see if I can play with the signs so that we'll get an outer and inner product that adds up to a minus 7x. Well, let's see. I'm thinking 3 and 2. Let's see. If I put 3 and 2, I'll have, for the inner product, I'll have a 3x and 6x, and there's no, I'm sorry, 10x. And yes, I think that'll work. The outer product will be 10x. The inner product will be 3x. Now again, I have to play with the signs. And yes, indeed, I can get a 10x and a 3x to add up to a minus 7x if I play the signs right. I think this will do it here. If the 2 is negative and the 3 is positive here, let's try it. The first product is 5x squared. The outer product is negative 10x. See what happens with that negative sign? And the inner product is plus 3x. And the last product is minus 6. So indeed, this does check out. If you combine the inner and outer products, they are like terms, and indeed I do get what I need. This answer checks. So the final answer here on that second line, that is the final answer, 5x plus 3 times x minus 2. And again, multiplication is commutative. You can't change the position within parentheses, but certainly I can change the order of the parentheses here for an equivalent commutative answer. All right, let's move on to the next example in our text. Example 3. Factor. Oh, this is on page 427. 427. Hang on. Page 427. All right, we are asked to factor the following trinomial expression. 8x squared plus 33x plus 4. Now, I get a little nervous here because I see an 8 in the first slot, and 8 is certainly not prime, so we might have to consider quite a few possibilities here. 4 certainly is not prime. We could have 4 times 1 or 2 times 2. All right, let's see. Let's see if we can narrow down our choices here. This last term is positive. So that means the signs in between either have to be positive, positive, or negative, negative, right? If this sign is also positive, that scratches out the negatives, so we know the signs in between both have to be positive. So that helps us quite a bit right off the bat. All right, so I know our factored form is going to look something like this, and I have to fill in the blanks. Well, I've got a couple of choices here. For the first slot, I get 8x and 1x, or I could use 4x and 2x. Now, only one answer works. It's only one of these layouts is going to work, and I need factors of 4 in the last slots here, such that the outer and inner products add up to a plus 33x. Now I know that 4 times 8 is 32, and this is kind of a large number relatively in the second coefficient here. Let me try a 4 here, because then if the inner product is a plus 1x, the outer product will be 32x, the inner product will be 1x, and that indeed adds up to a 33x. So I think we're almost there. Let's check our answer. If I multiply these binomials, do I indeed get what I started with? Let's try it. 8x times x, the first product is 8x squared. The outer product we know is 32x. The inner product is 1x, or just x. And the last product is 4, plus 4. So I get 8x squared plus 33x plus 4. Indeed checks out. So this I didn't have to mess with because I found a combination that works. Only one factored answer is the right answer. Of course, you might reverse the order of multiplication here without changing the quality of your answer. All right, but certainly 4x and 2x aren't going to work in the first slots. All right, final answer, and equivalent to final answer. All right, up the ladder we go. Let's look at example 4 on page 2428. We are asked to factor, again, a trinomial. Here it's 25t squared minus 10t plus 1. All right, well, I can think of two possibilities to start with here regarding the first terms. Let's see if we can narrow things down a little bit. If this sign is positive, the signs in between have to be plus plus or minus minus, right? As we've talked about before. Notice the first degree term, the degree 1 term here, is negative. Well, that rules out the positive option here. So I must have negatives in both the middle signs in this expression. So let me fill that in. All right, it must be minus minus in both scenarios here. Now what I'm doing here is listing different possibilities for the first terms here. Well, 25t squared, I could either have a 25t and a 1t in the first slot, or I could have 5t and 5t in the first slots, and that's pretty much the only options I have, at least regarding the first terms. All right, I think I see something here. Maybe you see it too. The last product has to be a positive 1. There's only one way to accomplish that, with a negative 1 and negative 1 in the last slots here. All right, and if we look, the outer product and inner product are both going to be the same here, minus 5t, minus 5t, and that indeed adds up to a minus 10t. So my final answer here is 5t minus 1 times 5t minus 1. Once you've found an answer that works, it's unique, at least up to reordering of the factors, but the factors here are the same. 5t minus 1 times 5t minus 1, and, well, of course, I think our author would write our final answer like this. When you're multiplying the same factor times itself, I could clearly call it 5t minus 1 squared. Final answer, quantity 5t minus 1 squared. All right, let me get a fresh screen. All right, this is example 6. I want to illustrate next example 6 on page 429. And this one's a little nastier still. Not too bad, though, if you think about it for a minute. We're asked to factor 6a squared plus 19ab plus 3b squared. This is still a trinomial. It's still a degree 2 trinomial. But notice we got more than one variable. The first product looks like it's going to be 6a squared. The last product will want to be 3b squared. All right, so in the first slots, I'm going to need multiples of a. In the last slots, I'm going to need multiples of b. And that's okay because the outer and inner products will be multiples of a and b. All right, this sign is positive. Again, the terms in between, the signs in between must be either plus plus or minus minus, right? Notice this first degree term, or second term I should say, is also positive. Well, with that we can scratch out the negative options here. Okay, it must be of the form plus plus. All right, so let's go ahead and put plus and plus in between these two binomials. I'm looking at 6a squared. Well, again, 6 has got two different possibilities. I could have 3a and 2a in the first slots, or I could have 6a and 1a, or just a in the first slots. Not sure which one's going to work. Let's see. I think I see something here. If I try 6a and a in the first slots, let me try that. Now I'll try to adjust my last slots. Again, you want the last product to be 3b squared. Well, there'll have to be multiples of b in the last slots, and the 3 is, of course, is prime. So let's see, 19ab, you want your outer and inner product to add up to a 19ab. If I put a 3b here, the outer product will be 18ab. If I put a 1b, or just b here, the inner product will be ab, or 1ab, and that indeed ensures the inner and outer sum will add up to a 19a times b. All right, so I think this will work. Let's check it. 6a times a is 6a squared. The outer product is 18ab. The inner product is b times a, or I'll call it plus ab. And the last product, b times 3b, is plus 3b squared. So indeed that does check with what I need. Final answer is 6a plus b times a plus 3b. And again, you can't go picking things, moving things around within the parentheses, but I could change the order of multiplication here and get a totally wonderful equivalent answer. All right, final answer, 6a plus b times a plus 3b. All right, we can play this game again with this, where your last term is a variable expression, not just a constant. Let's look at example 7. This is on page 429. All right. Example on page 429. Factor the expression 6x squared minus 13xy minus 8y squared. All right, again, I've got a first term that's a multiple of x squared, a last term that's a multiple of y squared, and a middle term that's multiples of both x and y. So I think I can do this one similar to the previous one. It's a little more complicated because this last term is negative. That means I have to allow for plus minus, or minus plus here, in the middle sign slots, we'll call them. So let's consider our options here. I think I'm going to start with 3x and 2x in the first slots. Those indeed add and multiply to 6x squared. All right, I'm going to need multiples of y in the second slots. And let me see, my 8's got a lot of possibilities. 8 and 1, 4 and 2, 2 and 4 and 1 are 8. And again, with plus or minus options on each of those sub-options. So let me think for a minute here. I think we can do it with, let's see, I'm 8y here and a y here. I'm not going to consider the signs right away. Clearly we're okay with the first product. Let's look at the inner and outer product. Well, I know the last product is going to multiply to 8y squared. So the last terms are okay here. Can I force the inner and outer product with sign considerations to add up to a minus 13xy? That's what I need. All right, I think so. If you look here, the inner product, again, not considering the signs yet, is 16xy. And the outer product is 3xy. And of course, if I can get a negative sign on the 16 and a positive sign on the 3, then of course I will add up to what I need at 13 or negative 13xy. So let's put a negative on the 8y here. That way the inner product is minus 16xy. That's what I need. The outer product, let's see, put a plus y here. All right. And 3x times y is 3xy. Again, that's what I needed here. So I think we're all set. Let's write this down. 3x minus 8y times 2x plus y. And if you want to check your answer, fine. The first product is 6x squared. The outer product is plus 3xy. The inner product, again, is minus 16xy. And the last product is minus 8y squared. And then we know that plus 3xy and minus 16xy do indeed add up to the correct middle term. Final answer right here. 3x minus 8y times 2x plus y. And of course, I could rearrange that order of multiplication. Can't move things around within the parentheses, but certainly I can reverse the order of the multiplied parentheses because multiplication is always commutative. All right, let's look at next example. This is example 8 on page 429, right at the bottom. We are asked to factor the expression 6x cubed plus 15x squared minus 36x. Make sure I copy it down right. All right. Always, in any factoring problem, always look for a GCF first. Now, that means a GCF that's not 1 or negative 1. You can always factor out a 1. That doesn't make much sense. You can always factor out a negative 1 by just changing the signs. That's not very meaningful. But clearly, if I look at this expression, 6x cubed plus 15x squared minus 36x, I can find a GCF, right? The greatest common factor of all these coefficients is, of course, a 3. So I'm going to be able to factor out a 3. And, of course, I've got at least one factor of x common to all 3 of these terms. So I can factor out a 3x first. All right, so let me do that. Factoring out the GCF first, I get 3x times. I'll get 2x squared plus 5x minus 12, right? All right, good. All right, now what I can do again is look at this trinomial that remains and see if we can factor that again. So don't forget to carry your GCF down to your final answer. All right, if I can break this trinomial down into a product of 2 binomials further, I'll need 2x and x in the first slots. Let's see. 4 and 3, I believe 4 and 3 will work in the last slots. If I write it like this, check it out. Your outer product is 8x Your inner product is 3x, and I can play with the signs for 8x and 3x to add up to a positive 5x. I'll make the 4 positive and the 3 negative. And I think we've got it here. First product, 2x squared. Outer and inner products, 8x minus 3x adds up to a plus 5x. And the last terms, minus 3 times 4 is minus 12. Here's my final answer, and please don't forget to carry your GCF down to your final answer. It's a common mistake to leave it hanging upstairs somewhere, okay? All right, and of course you could change, well, you've got 3 factors here now. You could change the order of multiplying these expressions, but they're all equivalent and all correct, okay? I'd like to do one more exercise to call it a day. This is number 67 in your homework list. This is on page 535 in the exercises at the end of the section. And since it's the last problem, it typically represents the upper limit of difficulty for us in this section. Let me write it down. It looks a little intimidating, but I don't think it's so bad if you take things a step at a time. 4x to the 4th plus 8x cubed y plus 3x squared y squared. Oh, by the way, I want to be sure to give the magic word. The magic word for today is mango. Mango, M-A-N-G-O. Magic word for today is mango. Please remember that at quiz time. All right, so again, we want to factor this. And, well, always look for a GCF first. It's not always going to be there, but certainly we need to check for it, especially in a higher degree trinomials like this. Well, looking at the coefficients, 4 and 8 and 3, there is no meaningful GCF there of 1. All right. No, you can't factor out a 4 or an 8 because 3 is a prime number. Can't factor out anything from the coefficients if any of your coefficients are prime. But I think I can factor out 2 factors of x. And this first term doesn't have any y, so I can't factor out any powers of y. So the GCF here is x squared. So I can factor out an x squared. And I'll be left with 4x squared plus 8xy plus 3y squared. Okay? All right. Notice your first term here is a multiple of x squared. This last term here is multiples of y squared, and the inner term here is multiples of x times y. So I think I can factor this similarly to the last 2 examples. Again, this sign is positive. These signs are the same, plus, plus, or minus, minus. This sign is also positive, meaning we can ignore the negative, negative options here. All right, it has to be positive, positive, and those signs in between. All right. All right, so what's going to work here? Well, I think I see 2x. Let me try 2x and 2x in the first slots. 2x times 2x is 4x squared, so that checks out. The last products have to be multiples of y squared, and 3 is prime, so I need either 3y and y in the last slots or y and 3y in the last slots, right? And then so only one of those options is going to work. Let's see. If I pick the top options here, I'll get a 2xy and 6xy, and if I add those, it indeed adds up to 8xy. 6xy plus 2xy is indeed 8xy. All right, so let me erase this sub-option, and I'm going to put 3y and y in the last slots here. And I'll check my answer once more. I'll get 2x, 4x squared. 2x times 2x is 4x squared. And outer product, 2xy. 2x times y is plus 2xy. Plus the inner product is going to be 6xy. And those two indeed add up to a 8xy, and of course the last product here is plus 3y squared, but we knew that. So final answer, let me write it down without the side work, x squared. Be sure to carry your GCF down to your final answer. Plus 3y times 2x plus y. Now again, these are all multiplications going on between these expressions, so you can rearrange the order of these expressions any way you want. You can't change around the order within the parentheses though, and this is my final answer. All right, this concludes section 7.4, Factoring Trinomials, Part 2.